Hey guys, so this week's lesson is about matrices. It's something you've never seen before, but it's not too complicated this week. We're going to just do some very basic operations with matrices, kind of introduce them what they are, and then next week we'll get into some more complex things like multiplication, and then the week after that, then we'll get into how to actually solve systems of equations using a matrix and what all is involved with that. So, first off, just what is a matrix? A matrix is an array of numbers. It looks something like this, and it can have, I'll just put some numbers in here, 3, 4, 5, 7, 10, 11. This is a matrix that has two rows. Okay, rows go across, and it has 1, 2, 3 columns. If I could spell, it'd be fantastic. You know my issues with that. And so this matrix would be considered a 2 by 3 matrix, because it has two rows and it has 3 columns. And the way you name a matrix is rows by columns. And so this would be a 2 by 3 matrix. I'll make another matrix up here. We'll go with 1, 4, 8, 10, 2, 12. Doesn't really matter. This matrix has 1, 2, 3 rows, and it has 1, 2 columns. And so this matrix would be considered a 3 by 2 matrix because it has 3 rows and 2 columns. So the way you name a matrix is by rows by columns. And each little part of a matrix, each little number that's on the inside, here, 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 each one of these is called an element of the matrix. Okay, each number is an element, and again, it's a way of arranging data, and being able to then you can perform operations on matrices using that data that's arranged. And the first thing we're going to perform on it is just simple addition. We're going to add two matrices together. Now these two matrices, they're both 2 by 2, meaning they're 2 rows and 2 columns on each one. The first thing we have to know when we add or subtract matrices is that they must be the exact same size. Okay? When you add matrices, they have to be the exact same size. You can't have one that's 2 by 3, another that's 3 by 2. Or you can't have one that's 2 by 3 and another that's 4 by 1, or anything like that. It has to be exactly the same size. And since this is a 2 by 2, and this is a 2 by 2, we can in fact add them. And so what we do is kind of what you think you would do. We would add the elements together that are in the same locations. And notice what I'm doing here is I'm underlining the colors that are in the same locations here. And so in the upper left, that's 3 plus negative 1, which is 2. And then in the upper right, that's 0 plus 4, which is 4. And then in the lower left, that's negative 5 plus 2, which is negative 3. And in the lower right, it's negative 1 plus 0, which is negative 1. And our resulting matrix would be that right there. So you literally just add the values that are in the same locations when you're adding matrices, which is exactly why they have to be the exact same size, because if they're not the exact same size, then you're going to end up having some elements without a match. So they have to be exactly the same, such as this one. In this example, I've got a 2 by 2 matrix, and I'm trying to subtract a 2 rows by 1 column matrix. It can't be done, can it? Because they're different sizes. One is 2 by 2, the other is 2 by 1. And so if they're not the exact same size, I can't do it. And so what we do for this is we write in it does not exist. Or short, you can write in DNE. Does not exist. The result of this matrix does not exist. You cannot add the two matrices that are different sizes. Another thing you can do with matrices is you can multiply them by a scalar. Okay, this is not the same as multiplying matrices themselves, but you can multiply a matrix times a scalar. So if I take a number, say k, and I multiply it times a matrix, and I'm just going to put in some letters here, A, B, C, and D, make this a 2 by 2 matrix. I take that scalar and I multiply it times every element in the matrix. K times A, K times B, K times C, K times D. And that's all there is to it when you multiply by a scalar. Okay, you literally just take the scalar times every element in the matrix, and then if there's any other operations to perform, like addition or subtraction to it with another matrix, you can go ahead and do that at that point. So for example, say I've got this one right here. I've got 4 times the first matrix plus a second matrix. And so we perform multiplication before we perform addition, because remember of the order of operations. And so I'm going to take 4 times every element in the first matrix and then add it to the second matrix. And so in the first matrix, take that times 4, so 4 times negative 2 is negative 8. 4 times negative 8 is negative 32. 4 times 5 is 20. 4 times 0 is 0. And then I'm going to add it then to the second matrix. And again, I can perform that operation because both of these matrices are 2 by 2. They're exactly the same size, so I can perform the operation. And so negative 8 plus negative 3 is negative 11. 20 plus 6 is 26. Negative 32 plus 8 is negative 24. And 0 plus negative 5 is negative 5. And so my final answer is this resulting 2 by 2 matrix. Negative 11, negative 24, 26, and negative 5. One last thing I want to show you today. Something that looks like this. I'm not going to actually go through and perform the operations on this since I've already done an example like this. I just want to show you that something like this does exist to make it easier when writing problems on our end, on my end, as a teacher. Sometimes you'll see up at the top, you'll see matrices defined up here. I've got A, B, C, and D all defined as those particular matrices. And then down here, I want to perform the operation C plus 3D. And so all that means is that I'm going to take this matrix of C at 1.8, negative 8.8, negative 1.5, 3.4, 10.6, 0, and I'm going to add 3 times D, which is 7.2, 2.1, 0, negative 1.9, negative 5.4, and 3.3. And like I said, I'm not going to go through that whole operation, but I just wanted to show you that this does exist, and you will see this on the mastery quiz that we'll have, and you'll also see this on the worksheet, I believe, if you go through and practice those problems. It just makes it easier on us when we write problems to define the matrices at the top and then have you give you the operations down here at the bottom. Using just the letters of the matrices defined. So just know that exists and that's how that works. So I will go ahead and post this video online, and if you have any questions, feel free to join me in the Zoom.